Today we are going to talk about memory management. If you have any questions, you can ask them in the comments below or email me. First, I'm going to explain some basics about how computer memory works. For the computer science students, this has already been covered extensively in computer organization, so this is mainly intended for the mathematics students. After that, I will go over a simple implementation of a linked list. If you want to skip ahead, there are timestamps to the different sections in the description. To fully understand how you can use the memory when programming, it is important to understand how it actually works. Inside every computer there is a motherboard. On this motherboard there is a central processing unit or a CPU. This is where all the calculations are done. Close to the CPU there are strips of memory. These memory modules combined can be thought of as a long list of memory locations. Every location in this list has a single address. In this list you can save variables. Primitive types can easily be saved in these memory locations. For example, over here you can save an integer in the memory location with address 1000 and a character in 1001. But if you want to save, let's say, an array in 1002, the array itself isn't actually saved in that memory location, but somewhere else. For example, in 2000. In 1002, you will store a so-called pointer to the memory location where the array is stored. So 1002 gets the value 2000. The memory is divided into two important parts, the stack and the heap. These two parts have different functions when programming. First, let's talk about the heap. In the heap, all non-primitive types and global variables are stored. So basically all the arrays and objects. They are stored at an arbitrary location, and when the program is not using them anymore, they are automatically deleted by Java's garbage collector. The stack is built up of stack frames. Whenever you call a function, it gets its own stack frame. The first thing stored on the stack frame are some values the program needs to know what to do exactly when the function is finished. For simplicity's sake, we're just going to leave this part out. After that, all the arguments are stored, and after that all local primitive variables and pointers are stored. The stack is a literal stack of these stack frames. Whenever you call a function, a new stack frame is pushed on top of the stack, and when the function is done, the stack frame is popped off the stack. Now, how is the memory used with objects? Let's look at a simple linked list. Right here in this example, there is a very basic implementation of a linked list. Usually you would add more functions like get and set next and get value. I didn't do that this time to save some space. So we have two functions. The first function foo creates a linked list with the values 2, 3 and 4 in that order and stores it in a global variable. The function bar then cycles through this list and prints all its elements. So what happens in memory? First of all, before we call any of the functions, the variable first already has a value, namely null. This is stored on the heap because first is a global variable. When calling foo, the function would normally get its stack frame. I left it out this time because there are no local variables. Then in the first line of foo, first is assigned a value. In the heap, space is reserved for one node, so an integer and the pointer to another node can be stored. Then the values are filled with 4 and null respectively. The same happens in the next two lines, but now instead of saving null, the value next in the node becomes the previous value of first. This way you get a linked list. Then when you call bar, the variable node is created on the stack frame. First the value first is copied to node. So now both first and node point to the same element. The value of that element gets printed and then next is copied to node. This process is continued up until the point where the value of node is null. So that's it. If anything is unclear or if you have any questions, feel free to email me. See you next time.